Hello, and welcome to another enthralling episode of Science. Today we would like to talk to you about 2,4-dinitryl-phenohydrazine. I am joined today by Blake.
Hello.
Harry.
Hello.
And Rossi.
Hey.
This is a molecule of dinitrophenohydrazine. As you can see, there's these two groups that stabilize the molecule, and this is the explosive element. Moving on. The main topics we would like to discuss today are what is 2,4-dinitrophenylhydrazine, abbreviations and AKA for 2,4-dinitrophenylhydrazine, uses and reactions of dinitrophenylhydrazine, handling, precautionary statements, and alternatives to diphenylnitrohydrazine. Moving swiftly on. What is dinitrophenylhydrazine? Well, first of all, it is difficult for me to say, so we're going to introduce you to the abbreviations. The main abbreviation that is used for dinitrophenylhydrazine is DNPH, or 2,4-DNPH. It is mainly used in Brady's reagent. And here you can see the precipitate formed when Brady's reagent is used to detect aldehydes and ketones. Now I'd like to pass you over to Blake.
Hi, I'm Blake, and I'm going to be talking about the uses and reactions of DNPH. So DNPH is used as a quantitative test for identifying carbonyl compounds. Brady's reagent is used, which is a mix of methanol and sulfuric acid, and when this is added to your sample, bright orange precipitate will form if a ketone or aldehyde is present. However, this test cannot identify carboxylic acids, so this limits the range and uses of substances that it can identify. But it's still a quick and easy test that is accurate. The best thing about DNPH is that other than detecting the presence of ketones and aldehydes, is that it can identify the exact ketone or aldehyde. This is done by filtering and washing the DNPH derivative, with methanol to obtain the crystals. The melting point of these crystals is then taken and compared to an online database where you can find the exact ketone or aldehyde. This is accurate as the range between the melting points is quite large, so you can obtain a high certainty of which ketone or aldehyde the sample is. This can be a tedious and long process, but it still provides accurate results. While DNPH is very effective, alternatives are needed due to its explosive nature. Some of these alternatives include Tollens reagent, also known as the silver mirror test. This can only identify aldehydes though, so this isn't really good enough. Another alternative is PERPALD. This is safer but still flammable, and will react with ketones and aldehydes, but will form a purple color with aldehydes once the cyclic derivative oxidizes in air. This is a good alternative, however, it cannot identify the specific ketone or aldehyde. So these alternatives aren't better practically, but they're better in terms of safety. Now Harry is going to talk about the mechanism of DNPH.
2,4-dinitrophenylhydrazine reacts with the carbonyl group in a ketone or an aldehyde. The oxygen from the ketone or aldehyde creates a double bond with the nitrogen. The two H's and the O come off together and make a water molecule. That's why it's known as a condensation reaction, because a small molecule is created when it happens. Now on to Rosie.
Hey, I'm Rosie. I'm going to talk about the handling of the nitrophenyl hydrazine. So, it's used in many schools because it's quite safe when stored correctly. When it is wet or in a solution, it is quite harmless. But if let dry, it can be subject to explode. It can explode, subject to friction, heat, or shock. Okay, so now I'm going to talk about some personal protective equipment when handling DNPH. So, like in most experiments, you will need glasses and full body coverage. But here you also need gloves because it causes skin irritation. And another thing that you might need in some of the experiments is respiratory protection. And also here I want to mention that those lab coats aren't contaminated. Okay. Oh yeah, and every time you're in the lab, if you have long hair, you have to tie it back. Not like I'm not in lab now. Next. Yeah, and for the precautionary statements, DNPH is highly inflammable, so you should keep it away from heat and open flames. Another thing is you shouldn't swallow it. If you do so, you should immediately call a poison center. And in case of fire, you should use dry powder or dry sand to extinguish it. So now Harry will talk about history.
"600 universities and schools across the country were visited by bomb squads between October and December of 2016. This was because, as previously mentioned, when 2,4-dinitrophenylhydrazine dries out, it becomes a shock explosive. So don't leave it open for a year and then throw it on the floor. All of the schools and the academic staff in the schools and universities were were contacted to remind them to make sure that their 2,4-dinitrophenylhydrazine was being stored properly. And this caused a lot of commotion because all at once, a lot of them realized that a lot of them were quite worried about the conditions that it had been stored under. Which is why the bomb squad was quite busy at that time. There are safer alternatives which have come about. Well, they were still there, but now they're used more often. They're actually replacing 2,4-dinitrophenylhydrazine. Some of them are being mentioned here. One of them is 2,4-dinitrophenylhydrazine, but instead of being stored wet, this time it's now stored in phosphoric acid, because then it won't dry out if not stored properly and blow up. One problem with storing it in this way is that when you actually use it, you'll have to remove the phosphoric acid from the product if you want a pure product. Now, for the summary.
Hello again, and thank you for listening to our presentation about 2,4-DNP. I hope you've enjoyed it, and if you have any further questions, please head down to the library and find a book. Thank you. Goodbye.
So mention the carbon hub.